Hello and welcome back to Machynlleth. In this video I'm going to be rebuilding this signal. I originally built it about 2 years ago, but it's got damaged in the meantime. I managed to connect it up to a too high a power supply and pop the LEDs in the lamps, and also the mechanism connecting it to the servos is now broken, so it needs a complete rebuild. So I'm going to start from scratch and show you how I make them. So I'm just going to ease the old signal out. So here you can see how it's connected with the servos and wires for the servo control and the lamps. So we'll take that inside, we'll start taking it apart to salvage the useful pieces, and we'll start from scratch. So if we look at where we are, we've got these two micro servos here. This one, as you can see, does still actually work, although it's a bit stiff, which, as you see, it's catching. So we need to make that mechanism a bit freer. See, there we are, that still works. This one's wire has unfortunately snapped down here, so no longer connects to the servo arm, and also, as I say, the LEDs have both popped. So the LEDs are embedded in the lamps up here, so we need to rebuild this with a new post and bracket, and while we do that we need to bury the wires for the LEDs down the posts, through the bracket, and then down the side of the main post down to an LED, sorry, a resistor down here, and a little plug so it can be connected up to the power supply for the rest of the layout. This is a little bracket that I designed just on the laser cutter for holding the signal and holding all the servos together. So what I'm going to be using, I've got some leftover sprues from the Ratio GWR square post signal arm sets. I'm going to be using the long main post and a bracket dowel there. Won't be using any of these. It's fairly unique to the Great Western, to the Cambrian sort of bracket there, which is made from evergreen strip. Might need to use a bit more of the sort of platform stand bit. I might recycle that. And for the arms, if I can't recycle them, I'll show you. If I can recycle them, I will. If I can't, I will at least show you how to make a convincing arm out of these model signal engineering brass etches, which are much more convincing than the Ratio offering. So I've salvaged what I can out of their original signal. I've got the two arms, although I'm going to need to put new axles onto their pivots, the ladder, some brass cranks, some dummy balance weights, and I think, hopefully, although they're a little bit bent, some white metal finials, although they've lost their little pegs that they insert on, so they might not work so well. I've also managed to preserve the base plate and bracket that holds the servos. This is something that I've designed and made myself on the laser cutter. It's just a simple base plate with some holes to take a pin in the bottom of the signal, some holes for the various wires to pass through, a couple of holes for screws to hold it into the baseboard, some holes for these tiny micro servos, which are the servos recommended by Megapoints, whose servo controller circuit board I use. And then on the side here I've got a sort of a small plug with a resistor on the positive side. So on the positive side I always make a little mark of paint so I know which side is which, that we can connect the LEDs to. It's worth noting that these micro servers actually come with a non-standard small micro 3-pin plug that doesn't fit the usual servo controller plug, so I've just spliced on some normal servo plugs onto the end of their wires. So it looks like we'll be able to reuse all of that. So I'm going to start with the long hole. Will need a bit of tidying up. This one, yep. So I want it the same size, so I'm going to cut it down about there. There we are. And I don't need this bracket and lamp, so I'll remove them now. Okay, so there's quite a lot of flashing on that. I'm going to tidy that up with a file. I am going to use the original ratio lamp. I know some people like to replace them with cast versions, but in this case, because I'm going to be putting an LED in there, I don't want any metal in there to short circuit the LED. At this point I'm just going to put a little peg in the bottom before it starts getting too delicate. I'm just going to drill a 1.5mm hole in the bottom. Try to keep everything as perpendicular as I can. Yeah, that's fairly straight. And then this is just a piece of 1.5mm diameter brass tube which can fit in the base. That's working fine. A trial run, so I'm just going to super glue that in now. Ooh, rather a lot. And that is just so that I've got a little anchor to fit the post onto the base. So next thing, I need to start thinking about these, where these wires are going to go. So these are the micro LEDs I'm going to use. I picked them up at a show, don't ask me who supplies them, and they are absolutely tiny. They are 0.8 millimeters wide and about just over a millimeter. Yeah, just over a millimeter long. I'm on some tiny little wires with a resistor soldered onto the positive side, wrapped in shrink tube. I'm just going to test that. I always test it with the resistor or you'll pop them. So just gonna untangle this one. They are very fiddly. So there we are. That says it's warm white, and that's running fine off a 12-volt battery with the resistor. Basically what we need to do is on the correct side of the lamp, so the lamp side of the lamp that's going to sit behind our spectacle plate of our signal arm, LED needs to sit inside that lamp. So we need to drill a little depression in there. As the lamp comes, there's actually a little sort of lump there to represent the lens, so we need to get rid of that and drill a hole to receive the. I'm just going to start off by filing the front of that lamp flat. Then with a pin vise I'm just going to make a pilot hole so that my drill bit goes in straight. 1.5 millimeter drill bit. I'm just going to make a little depression. So I'm not drilling all the way through the lamp, I'm just making a little depression in the front that the LED will sit in. Not sure if you'll be able to see much of this, but there we go, so that will fit in there quite nicely. I'm also at this stage going to just cut a little track out of the side of that depression for the wires to come out. Wires will come out of the lamp round the bracket, and then we need to make a trough all down this side of the post that the wires from this and the doll, the bracket signal lamp will travel down inside, buried in the side of the signal post. So probably the best way to do this is start off with a ruler and a scriber from as high up as I can get, holding it nice and firm, is just start to make a channel. and this can guide a file to make the channel deeper. So hopefully you can see now that there's a little channel starting to appear down there. Now I've got a little triangular file. I'm going to start using the point of that. It will follow the track that you've made to open this channel out as wide as we can. Remember, we've got to get 4 wires down this. They're only thin, but they've got to be completely buried. Just file some of that swarf away. It's not a mess. So you can see now that our LED's wires will fit in that track, and we can bury them with filler. So now I'm just going to take one of the bracket signal arms off the sprue and prepare it in the same way as I did the post. So again, we only need 1 lamp. Cut off all these extra bits and pieces that we don't want, little bits of flash. It's a much shorter dowel post than is provided, so we're going to cut that down as well. Just measure it up against the other one for convenience. Make a little mark there. Cut across it with a saw. Okay. We'll remove that, tidy up the lamp like we did before. Got a little exit channel for the wires. So I haven't quite decided whether I'm going to be able to salvage those dowels yet, the finials yet. So I'm leaving these finials in place in case I end up using them. The other thing to do at this point as well is to drill out the holes to take the axles for the signal arm with a 0.5mm drill bit. So I've tidied all that up, and similarly on this one I'm going to make a channel on the lamp side. The wires doesn't need to be quite as thick, quite as deep as the channel on the main post, because we're only hiding 2 wires. There we are. So next we need to make the platform, which, as you can see in this one, is a bit of the ratio platform moulding, and then underneath we make a little tunnel that the wires can travel under before coming across into the main post. So luckily I've got a section of the wooden slatted sort of platform walkway on an old signal sprue from Ratio, so we'll use that. And I'm going to measure it, how long it needs to be. I need to go up to that. That plank there. Just cut that off, and then just use that as a guide. Cut a little bit of that off. A little file. That's quite good. So there we go. Now as you look under here, there's a nice little channel there that we can use to hide our wires. So as I'm copying like for like, I'm just going to make a mark at the level of the walkway to guide where that's going to glue in place. Now I've got a piece of 1mm square evergreen strip, which I'm going to use along the front of the bracket here and to make this piece here, just to make it a little bit more solid along the front. So I'm going to cut a bit that's a bit oversized to start off with, and I'm just going to glue that over the front here to create a little square hole there to hold the post in, just with some poly cement. Make sure it runs in okay. So that should now grip the pole a little bit better. And the same along the back there, just to support these sort of floating slats. So there we are. That will almost hold itself on now when we come to glue it in place. So I'm going to make sure that that needs there's a little bit of movement in there, so I might just build that up just to make the bond a bit better. So before I can stick this into place on the platform, I'm going to have to get the LED in, otherwise the wires are going to have to try and poke through that tiny little gap here, so it'd be much easier to glue this on with the wires already hanging down. So before we do that, I need to remove these not LEDs, resistors, because eventually they've got to poke through a tiny little 1mm hole down the side of the post on the base. And these LEDs come with 2 black wires, which isn't too helpful, because we need to remember which one's positive and which one's negative. So before I cut resistors off, I'm just going to coat the bottom bit of wire, and I found the best thing to do this with is actually nail varnish, because it dries really quickly and it remains fairly flexible, so it doesn't all crack off like some paints I've used have. And I just have a convention that I put red on the positive. It's fairly easy to remember. Alright, so here comes the tricky bit, is trying to glue the LED into that hole and the wire down the channel, because no glue seems to do the job on its own. Super glue doesn't stick well to plastic, it sticks much better to your fingers and you end up completely stuck to everything. But I did find this called Q-Bond, which is a liquid super glue and a little reinforcing filling powder which will fill the hole as well, but makes the super glue, it sort of accelerates the super glue. Right, I'm just holding this in a vise just to give me an extra hand, so I put a tiny bit of super glue into that depression, and then making sure that our LED is pointing outwards. With the wires and the little channel that we made, we can pop the LED into place. I hope you can see that with my finger there. Then I'll just use this little scriber just to grab a little bit of this stuff, dab it on like that, and it does seem to accelerate the sticking process, so that's reasonably well stuck now. And just to check that everything is still working, I'll give it a little test. Yep, so there we are. So now with the LED firmly in place, wrap the wires around the bottom of the bracket and they should sit nice and neatly parallel in the little channel that we've made, and I'm just going to hold them in place at the bottom with a peg. So now we've got to try and glue plastic that doesn't want to stick to plastic into that groove. So holding it in place, get a little dribble of the super glue. You can usually just tease it into place, just running, you know, with a small object up and down it until the super glue goes off and it wants to stay in place. Because it's not behaving, I'm just going to use a little bit of this again. Hopefully That will convince the wires to stick in place. Right, so we've let that dry. Now I'm just going to fill that groove up with a bit of plastic filler. This is Revel's one. I must admit this is a lot runnier than it normally is, so we'll see how this works. Might need a few coats. So it's better to overfill it, and then we'll sand it back once it's dry. So that's dry now, and it's actually filled that channel with just one coat, so with some very fine sandpaper. Just gonna make sure that it's gonna look mainly flat. I don't want to sand it back too much and start damaging the wire. Make sure the bits where it's spilled over the edge created a little lip. Okay, so there we are. So we've got our buried and pretty much invisible wire. And seeing as it's the next step, we better check that we haven't damaged it in any way. So just with our battery, we'll just give it a little check. No, still working. So now we can glue our post onto the platform like so. That's a nice interference fit now, so just a bit of cement into the gaps, and we just leave that. And now I want to box the wire into this little groove between the supports for the planks. So I've got some very thin plastic card here. I'm just gonna, just like it needs to be about 3 millimeters wide, so I don't need to be particularly accurate, I don't think. So that should fit over there. Just going to make sure those wires fall into that channel nice and neatly, and a bit of cement on either side. And there we are with our wire now nicely concealed. It's time to attach that onto the main post. So made my little mark where it wants to be. So we've got these two wires that now need to pass through the post so that they come out on the side with our groove. So I've now got a 1mm bit in my hand drill, and from just underneath, and then angle it towards the level that you want. I'm just going to drill a hole carefully all the way through the post. So you can see how that's going at a slight angle just to aid the passage of the wires. And now this is where marking the positive was essential. We're going to have to cut off that resistor to get it through the hole, so that we will still know which one is positive. One through, and the other through. There, and come out and settle nicely in the grooves that we made earlier. So there we are. I'm just going to a little dab of cement around here. So that's starting to dry. It's not 100% stiff set yet, so I want to put this bracket here. So I'm back with my 1mm evergreen strip, and I'm just gonna use my fingernail to convince that to go into a sort of a curve like that, which is what the prototype is. So I'll cut off that with a bit of excess, and we can glue that in place now. Right, so with that setting, we now need to put our LED in the main post lamp. So, same technique. We want a dab of super glue. In the little recess that we made for the LED. Pop our LED into the hole. Sprinkle a little bit of this magic dust over the top of it to make sure it sets. So that's now set, so we need to get the wire in the same way that we did on the bracket signal, and get a bead of super glue into the groove with the wire and just tease it in, try to get it to stay in there. It's really tricky to convince this stuff to stick in this groove. Hold it at the top end with these tweezers to keep the tension, and then just keep sort of stroking the wire into the groove as the super glue sets. Just trying to do short sections at a time, otherwise you pull it up and have to start again. And we'll keep working our way down. It might drive you mad watching me trying to do this. So there we are, we've got those wires nicely buried now. And let that dry. We'll put a bit of filler on, sand it down, you can move on. So that's all set quite nicely. That sandy stuff has gone rock hard over the top, so we just need to give that a sand back. Again, taking care not to go too deep and damaging the wires. So back to our Revel filler. Just smooth that over. So that's had 2 coats of filler. We just want to sand that back to make the surface appear smooth, to get rid of these lumpy bits off the side where it's sort of spilt over the edges. Up here we just need to be careful we don't damage the wire. So there we are, we've got a nice smooth post with wires buried down it that you can't see. Now in real life, the rod that actuates the signal arm usually has enough stiffness in it just to support itself the whole length of a pole, but I've found using very fine, I use 0.3mm brass wire, that it does have a tendency to bow if it's not supported in the length of a pole this long. So what I tend to use is, these are very small, but these are handrail knobs for loco construction, available probably from a few sources, but these are Alan Gibson ones, and these are the short version. You can get them in short, medium and long, and they're basically a knob with a tiny little hole through them that will accept 0.3mm wire. So what I'm going to do is I'm going to put a couple at this sort of level and one higher up, just to stop the rod from flexing when it's moved. I should probably have done that before I put the wire, buried the wire for the LEDs, because if I'm honest, there is a risk that I can drill through the LED wires, and I don't want to do that, so I've got to be a bit careful with this bit. Yeah, about halfway up the pole I will put a couple of holes for the handrail knob, so you don't need to drill all the way through, obviously, just probably about 2mm depth at the most, just enough to accept the handrail knob, like so. So I'll draw another one next to it. I'm going to go staggered slightly higher so that I can drill away from that outside edge where the wires are buried, and I can't see any wire through there, so I think I've got away with it. And one hole about halfway up the top of the arm. So when it comes to gluing these in, you need to make sure they're glued in the right direction. You want the hole passing vertically. So just a little dab of super glue in the hole. I've got a piece of scrap 0.3mm wire passing through the handrail knob, and then I can just pop it into the hole like that, and that makes sure that the hole is passing vertically. I'll just wait for that to go off, and we'll repeat the process with the 2 bottom holes. So hopefully you can see now what I'm trying to achieve. you can see that the signal wires, rods, move freely up and down through there, but what we do need is now they need to pass through or over these sort of bracket pieces, so I'm going to have to cut a very slight little groove in there for them to run smoothly through there. So there we are, we've got a little groove running through. Probably very difficult to see on the camera. There's a tiny little groove there and there. Just found the packet of original handrail knobs. That's what they look like when they're not painted. And I found some unused white metal signal finials, which are much better, I think you'd agree, than the ratio ones with their stems on them. So I can now afford to cut these finials off and drill a hole to accept these. Ooh, off it goes into the setting sun. That one. Just going to give them a little file across the top to make sure they're smooth and square. So I don't know if you can see the difference between the two there. These are Model Signal Engineering white metal castings with GWR signals, and they've got the little slits on the ball and the two halves of the casting line up, whereas the ratio two halves of the casting don't line up properly and there's no slits in the ball of the signal. So we'll measure it. The diameter of the stem for the finial is 1 millimeter, so I've selected a drill bit that's again around 1 millimeter. We need to make sure that that goes centrally into the end of this, which is going to be quite tricky because it's actually quite thin. So with a pin, point of a pin in my pin vise, I'm just going to make a little hole in the center of the top of the post to make sure the drill bit goes in centrally. So I'll swap the pin out for the drill bit. So go very slowly here because the post is not much wider than your drill bit. Don't need to go too far in. I'm going to cut those finial posts down, but you just need enough that they're going to stay in. If you cut them flat and glued them on the top, they'd probably fall straight off. So yeah, that is about that deep. So just going to cut the bottom of the finial off so that it will fit in the hole like so. So a bit of super glue and we'll get those in. There we are. They're looking much more delicate. So the next job is we need, for the bracket arm, there will be a crank in this corner here and another crank here in order for the rod to come up and move across there and then come up vertically up there. So I need to put a little bearing for that crank into these corners here. So I'm going to try and remove these bearings from this spare signal post. So I found the tricky thing is if you actually just try and cut them off the pole, you actually end up cutting through the hole, and you want to preserve the hole as much as possible. So I'm going to remove the lamp and then cut across the pole either side of the bearing, and then that will enable me to cut the bearing off, preserving its hole. So there we are, I've got the bearing with its complete hole. So this is so small and fiddly, I don't think you'll see what I'm trying to achieve. So this is what I've cut off, and this is what these tiny little pieces look like if you magnify them up. And I don't want the whole of the base because it's going to fit into a corner, so I just want to cut this bit off, discard this, so we're left with this sort of bearing with a little bit of a foot on it. So I hope you can see that. And the other thing I do at this stage is just pop a reamer through it, just to make sure that the hole is fully open. So from my last model, I know that I need to put one in this little angle here and one here. So I've actually loaded that up onto the tip of my very finest set of tweezers. I put a bit of glue on both surfaces, cement rather than glue. I want it to stand slightly proud of the post so that it's actually more in line with the footboards, so that it doesn't interfere with the movement of the crank too much. The same in this corner here. Bit over scale, but it will at least work. So that's just about it for the actual posts. I think it's about time I can give them a spray of white undercoat. While I do that, I think I shall make sure I've got something through these handrail knobs so that they don't bung up completely with paint, and then we'll start work on the signal arms. So just to make sure those handrail knobs don't bung up with paint, I've just popped a couple of little pegs of 0.3mm wire, and we'll go and give that a spray. Oh, the other thing I need to do is protect the lenses of the LEDs, and I'll do that with a tiny little piece of blue tack. Okay, that's had a coat of white primer, probably do with another coat, and I'll just remove our little protectors. So I think this is the point where I'm going to attach it to the base. Feeling these wires are quite vulnerable, it will give me a nice handle, if you like, to be able to paint the rest of the details, and I'd like to be able to check that my LEDs still work before I proceed any more. So if we remember back, the positive wires I painted in red nail varnish. I'm going to remove the resistor. This is the same resistor that's on there, it's just I've already pre-fitted that, if you like, and removed the heat shrink from around it, so I can use the bare wire to solder onto. So here, just for demonstration, is the laser cut base and bracket that I've constructed. So that's the base with holes for screws, a ladder, a little square just to show where the post is going to sit, and holes for the supporting peg and holes for the control rods to go through. And then as far as the bracket is concerned, just simple holes to take the servos and their screws, and that simply fits into a hole on the top, and that side piece just supports that, and that will just go together with some laser cut glue or PVA. So in order to get these through here, I need to get positive soldered onto this bit with the resistor. This is the same resistor as in here. I've just stripped back the heat shrink and already soldered it onto a little plug so that it can be detached from the power wires. So I've cut the positives, which, if you remember, we labelled with red nail varnish so we knew which ones they were, and stripped back a piece of that, and now just very delicately going to solder that. If I can find my solder. So delicate soldering, I tend to cut a tiny piece of solder off the length of solder. Some flux. That's the two wires twisted together. Pick my piece of solder up and just tin that end together. So I've joined and tinned the positive and negative wires together. So you can see on the base plate we've got a central hole to take the peg off the post, and there's a little hole this side for the wires to go down adjacent to the post, and these two holes here are to take the signal push rods. So I need to try and get these little tinned wires through that hole. There's one. And two. And then the signal pole, the signal post, will plug into that. So start with the positive one. I'm going to wrap that around our positive wire. and I'm going to solder that in place. Bit of flux. There we are. So I'm going to test that now with our battery, which I've lost. There it is. So I'm just going to pull that out and twist it a little bit so we can see. So making sure that we put the right polarity on the right wire, and you must do it this side of the resistor. If you test it at the other side of the resistor, you'll pop the LEDs, which is what I did on the last one. So positive on the positive, negative on the negative, and there we go, we've got two functioning LEDs. So now I can glue the signal post into position in the right orientation. And I will also glue these little wires into place with a bit of araldite, actually, so I found this the best thing to do with that, in order to make sure that they don't accidentally touch. So I've mixed up a little bit of araldite or any other epoxy you'll do, and just put a blob of it over the end of each of those wires. The next thing I want to do, I want to put a handrail around this platform area. Just going to make that out of some wire that actually came as the control rod wire from the ratio kits. So I'm going to just cut a couple of upright pieces, just roughly first, and then we'll trim it once we've got it all soldered together. So I'd say I probably want a support post sort of here and on the corner there, so that is approximately there we are, it's decided to work, approximately, let's say 14-15 millimeters apart. So I'm just going to mark that onto this piece of wood. And I'm going to tape this, which will be the handrail, in place. For the uprights, let's say we can trim these once they're in place. Let's see, a moment of truth. Yes, there we go, got a nice bit of railing which will go around there, and we can trim that to size as appropriate, but it's going to need a bit of shaping first. Looking at this from above, I want the rail to come out here, and then there will be a ladder coming up here, so a hoop that comes around the outside and then along the back and return to the smaller post. So the first bend I'm going to do is the bend to the smaller post. I've got this is a fine pair of pliers, just hold that, bend it back to 90 degrees, that's fine. And then to make the hoop, I'm going to use some round nose pliers, go out at sort of 90 degrees, and then hopefully that'll be approximately right. Yeah, pretty much first time. So I just need to make some little recesses to glue the uprights into. I'll make a little recess on this to glue this into. Must not file a recess on that side, because remember we've got wires running down that side of the post. So if we just cut tiny little V shape into here, this is just in an effort to get some purchase for any glue to stick into. So yeah, those are going to fit in there nicely. So just holding that in place where I want it, I'm going to make a little mark along there. I'm just going to make a little groove that the wire can sit in to hold it in place while the glue sets, like so. So the first joint I'm going to glue in place is this horizontal rail into the groove with a bit of super glue, and then some of the magic dust to help it go off, because again we're trying to glue plastic to metal. So just going to hold that in place for a minute or so. So that's stuck in place on the side. So similarly, just a little bead of super glue onto the uprights, and finally I just need to put a bit on here. Now I haven't got the luxury of having a groove to set the wire into here, because of the wires running down the inside of the post. So the tiniest dab of super glue there, and I'm just going to use this little peg to hold it in place. There we are. So you have to be quite gentle with this so you don't disrupt these quite fragile super glue joints. There we are. So we've got our railing in place there now. While I've been doing that, I've just made this little hoop that we can fix at the top here. So while those little rails are drying, I'll just show you these frets for the signal arms. These are Model Signal Engineering signal arm frets again. So I take an arm, they come as two parts. I'm going to use the short one because I'm just going to be doing this as a demonstration, and I tend to use the longer arms more. And a spectacle plate separately. So if you can see, both the signal arm and spectacle plate have 3 holes on a diagonal, 2 smaller holes either side. Those are to accept the control push-pull rod, and a center hole which is slightly larger to accept the axle. So we need to solder these 2 parts together so those holes line up with the axle in situ. So the first thing I'm going to do is drill a small hole in this piece of wood. So I've drilled a tiny little hole. It's with a 1mm bit, such that this piece of wire, which is just the control rod wire that comes with the ratio signal set, will go through it. So push the piece of wire through the center hole on the arm and down into your hole, so it sits vertically like that. So we'll have some flux. Again, we'll cut a tiny piece of solder, maybe a little bit bigger than that for this job. Settle that in the flux, and we'll just melt that solder onto the arm like that. Now we can introduce spectacle plate again over the center hole, and if you just hold that in place with the tip of your forceps, tweezers, forceps, and then if we heat the whole thing up, there we are, we can see the solder flash there, and we can pull that out of there, and we now have, it's a bit crude, I've put a bit too much solder on there I think, but you can see how we've now got a signal arm attached to the spectacle plate with an axle down the center of it, so it will move. So this bottom hole here we'll be needing for placing the control rod, so I'm just going to drill that out with a 0.5mm bit as it's filled up with solder. So that signal arm would just need painting, and then some tinted plastic from Model Signal Engineering again for the spectacle plates. So red in the upper spectacle for stop, and then as the signal moves down, it's actually a blue colour, not green, and that is because the lamp behind it would be an oil lamp, so it will burn with a yellow light. So yellow plus blue shines through as a green light coming through there, so don't be fooled into putting green perspex, plastic, whatever, into the lower spectacle. So fortunately I've managed to resurrect the original signal arms. In removing them I'd had to cut the axles, so I had to replace those. So I've managed to solder some new axles in without damaging them too much. I was a bit worried that the spectacle plates might melt, but they didn't. It's just going to need a little touch up in paint, but not a lot. So if we just offer them up, there we are. That's what the final signal is going to look like. Right, so it's about time we give them some paint. Now, first thing I'm going to do is I'm going to paint the LEDs, because at the moment, although they say they're warm white, if I demonstrate this, shining it through the blue spectacle plate, you can get a good contact. As we can see, it's shining through blue. So I'm going to paint those yellow, and trust me, it tones that very bright light down and it makes it yellow as well. So just using Tamiya yellow here. I'm just going to put a little dab of yellow over the front of these LEDs, and if we test that again, they're shining through green now. And next I'm just going to do the finials. I've got Tamiya red here. Now the slats on the little platform, I'm going to put in a sort of a beigey browny sort of colour, sticking to everything. I'm going to use this Vallejo sort of beigey browny colour, whatever you want for sort of worn wood effect. So there we are. You could go to town on a weathered wood effect if you want, but yeah, that stands up to the eye and everybody's going to be marvelling at your little LEDs anyway, rather than looking at the wood effect. So then we need to go through all the metalwork with some black, and I am using, where's it gone? My favourite black at the moment is Tamiya XF85 rubber black, which gives you a nice matte black effect. So anything metal wants to be black, so I'm going to start off with the lamps, because I want to get all around this yellow bit of the LED, just to make sure that there's no white light bleeding out of the side of the LED, so only the front of the LED is really visible. Here we are with everything nicely painted. And this signal arm's just temporary in place, they'll probably fall out. Yep, when I turn it over like that, well, there's a bit of paint come off there. We need to touch that up. So the next thing we need to do is this slightly more complicated fiddly bit of working out the control rods. Right, so we need to work out how our connecting rods are going to work. So there's a schematic here of a Great Western lower quadrant signal in the on position. So as I was explaining earlier, on this boss plate there are 3 holes that you probably couldn't see because they're too small. The centre hole contains the axle around which the signal pivots, and then 2 holes here in which you connect your connecting rods. So lower quadrant signal in the on position. If we want to move it to the off position, the signal moves down and the spectacle plate moves up, and the lamp shines through the bottom one. So these holes are going to move respectively up or down. Now you could do it either way. I prefer to connect the connecting rod to the lower one, so you get a push to make the rod to make the signal drop into the off position. Right, so I need to just plan how we're going to do our signal connecting rods and get them across the cranks onto the brackets. So this is a straightforward one. We will have a wire that hooks through the lower of the holes in the boss and travels straight down to the motor, the servo. This one, on the other hand, we need to get it across there with a series of cranks. So I've already placed a pivot here and a pivot here on the model, which you can probably see, and I've salvaged the old cranks because they're the same width. So here I hope you can see I've got the two cranks set up as a dummy, so that here push upwards makes the opposite crank push upwards as well, and same. To ensure free running of this crank, I'm going to put these tiny little sort of bearings, tiny little circles from the Model Signal Engineering etches over the pins, just to separate them so they don't get too tight up against the structure of the signal. This is super fiddly and you won't be able to see what I'm doing, I don't think. So I'm cutting off one for each crank, then hopefully, yeah, I can fit it over a pin before inserting it into the bearing. Do the same on the other one. So I've got the cranks in position now, and as you can see they're running freely. I'll need to put a tiny dab of super glue at the back of the bearings to hold that pin in place, and as you can see that's measured nicely so that both cranks are in a sort of right angle position, rather than one being in a right angle and the other one being slightly off. And as you can see, it works quite nicely. Now I've got to try and glue that in place without gluing the whole mechanism solid. So if I just get a tiny bit of super glue, that's way too much, hang up on the end of this screwdriver, and hopefully just dab it on the end of the bearings there without too much of it disappearing down the bearing with capillary action. Yep, we seem to be in business. So next I'm going to make the control rod for the main signal arm, again with 0.3mm wire. First of all we need to make a tiny little hook with a pair of pliers to fit in the signal arm. So a little hook like that, that's probably a little bit too long. I might just pinch a tiny bit back off that. That should fit in the signal arm from behind and one of these diagonal holes. Actually, it might be easier to thread the longer side through and then pull the hook through. There we are. Next we need to thread the wire back through the little handrail knobs. There we are. It's moving a bit more freely now. Okay, so that wire is brass, it's a bit shiny. I'm going to dull that down using a bit of gunmetal black. So this is what I use to darken off these. It causes a chemical reaction, so it it sort of permanently changes the colour rather than paint, which scratches off with the movement. So it's basically a gel. That's what they use for stopping guns from rusting. Best use an old paintbrush for this. It's like a gel, and hopefully you can see there that the colour is no longer shiny brass colour, it's changing to a sort of a, you know, black magic. Right, so that's looking a nice colour. Now what I'm not too happy with is there's a slight slant to how this wire comes out here. I want it to run up and down perpendicular. If you've got a slight slant there, it can be a bit prone to bending. So I'm going to put a little kink in it down here where it's not too obvious. So there we are. The advantage of having a kink in these is depending on the angle of the kink, you can make very slight adjustments to the height, to the length of your rod, if it's not quite lining up perfectly straight. As you can see, there's a slant here, so I'm going to do the same thing here to get it to line up with the crank on the servo. And then finally, with the signal in a horizontal position, I'm going to make a final bend forwards like that, and then cut off a small amount, pop it through the arm of the controller, sorry, the servo, and then I'm using these very gently to get a decent shoulder. I'm not cutting. There we are. I'll bend it down just to hold that in place. So as you can see, despite this, the tolerances are so fine. I had that signal arm in the horizontal position when I started, but actually that's got it in the off position. So using these little kinks, I can adjust. There we are. Okay, so we got our movement there. So the final thing with this arm is to put one of these spectacle covers on the back to hold it in place. I'll let my soldering iron warm up to do that. You need one of these little spectacle covers. Not quite sure what their proper name is, and another little spacing ring. Hopefully you can see that there. And I want to make sure that we leave a little bit of space to make everything run freely. So to do that, I get a small square of paper. I just poke a hole in the centre of it there. That can then slide over the wire axle. There we go. Protects a little bit because we've got to do this so without, I'm going to solder this without melting the bearing. So we've got to try and protect that a little bit. We've got to do some very efficient soldering where we just get in and out very quickly to avoid heating everything up around it. So I'm trying here to get this little spacer onto the end of the wire, and it's very fiddly. There we go. And then finally there we are. Just going to cut some tiny pieces of solder. Always cut a few more than you actually need, and some will be bigger than others, and you'll find one that you think is just the right size for the job that you want to do. So the advantage of having left the wire sticking up the front of the signal arm is it gives something to put a bit of pressure on. When you're doing a delicate soldering job like this, where you don't want to melt anything around it, whether they be other solder joints or bits of plastic thing, perversely you want a really hot soldering iron with a nice big bit, so that you can get in, get that heat to where you need it quickly and out again. If you go with a cooler soldering iron, it takes longer to warm the thing that you want to solder up, and that heat then dissipates into everything else around it. It leaks away, heating the whole thing up rather than the tiny little spot that you want. So I think I'm about ready to make this now. I just have a tiny little dab of flux. Got my solder ready. Clean the tip of the iron. Melt my solder on it. That's melted into a bead. So in, touch it, out. There we are. That's soldered. We remove the little paper washer. That's working perfectly, and now that's in place, I can cut this off flush and this off flush. There we are, one working signal arm. So we've got to do a similar thing with the doll arm. So I've got a piece of 0.3mm wire here. I've pre-blacked this with the gun black, gun blue. Again, I'm going to make a little hook to go through the signal arm. There we are. And now we can thread through. Okay, so what I'm going to do is I'm going to put a little kink in this so that we can just allow for some slight micro adjustments of the length of it, because it is virtually impossible to get it to the correct length. So try and line up the end of my pliers with the crank and make a fold up like that, and then I need to cut that fairly short. Now the fiddly bit of trying to get that through the crank, just try and turn that into a hook because it's going to be even more fiddly. So if we cut that, there we are. Right, try and get that through as a hook. That might be slightly easier. There, right. So we got that through as a hook. Good. So there we go. As I said, that I wanted that to be sort of a horizontal position. Let's see how that works with the cranks. Yeah, so the cranks aren't really bringing it up to the vertical position, so I'm going to straighten out that little bend that I made, which will have the effect of lengthening the rod. Okay, so before that all goes wrong, I'm going to solder a blinker on the back in the same way as before. So now all that really remains is to get control rod from the crank down to this lower servo. I don't know if you can see, made a little modification to the bracket. There's a little piece of brass there with a tiny little hole drilled in it, glued into a hole in there, and that's just to again guide these very flexible wires to stop them flexing between the base here and the servo arm. So I've got my piece of wire blacked up, I've made a hook on the end of it. So this is going to be a fiddle because we're going to have to get this into place before I can get it hooked up onto the crank. So through one, through the base plate, avoiding all the wires, through the little hole in the little brass support that I made. Right, so now I have to try and get this hook through here. might be something that happens off camera. There is an argument perhaps, I think, now to say that I should probably have done this before I fixed the crank down. Right, there we go. That was indeed a very lengthy little fiddle, which I ended up actually having to take the crank back off and replace it to get those little hooks in. But here we see, with a gentle push, we've got a good major movement of the signal. So now it just remains to attach that to the servo. So again, I'm putting a little bend in there so I can adjust the length, and I'm going to do the same here as well, just to get the rods running a bit more parallel up the arm of the post. So with the signal horizontal and the position, bend up the end here, cut it, and through. So that's with it in the horizontal, so I can bend these S's a little bit to try and, so movement of the servo is producing movement of the signal arms. Excellent, so we're nearly done there now. All I need to do here is, as I see, the black paint work there has taken a little bit of a battering, so I'll just touch that up, and then we're ready to test this on the servo control unit. I almost forgot actually, a ladder. This is an etched brass one from the now defunct Mainly Trains, which can now be got from Wizard Models, or part of Model Signal Engineering, I think. So I've already painted it up black with a section of white at the bottom for visibility, and the bottom of the ladder should, because I've already dummy run this, fit into, there we go. Should fit into the holes in the base plate. It's after a little bit of a wonk. And I can just super glue that in place. So there we are. Right, now we can go and try it for size, or try it for function either, with the servos connected up. So here inside my control panel is the Megapoints controller, which controls up to 12 servos and has a number of different modes, including point modes and upper and lower quadrant signal modes. It's quite a long-winded way of programming them in and adjusting them, but they can be completely adjusted just with pressing these little buttons here. If you want to know more about that, I suggest you go on the Megapoints controller website, and there's a very comprehensive video on there about people who know a lot more about it than I do. But I've managed to program it in, with just the simple use of a toggle switch. And there we've got a little bit of bounce and a bit of hesitation in the pulling off of the signal. So there we are. The more astute of you might have noticed, I've just noticed as well, I've forgotten to put the balance weights on the top. They're dummy balance weights, so they just need gluing on, and I'll attach the whole lot to its under baseboard wiring with its lighting in the correct place, and we're done. So there we are, with everything in place. Hopefully you can see the lights are lit now, and there we are. We pull that one off and back again. So there we are, we're in business.